Hello, hello, hello. If you're watching this, you missed day 2 of our week 15 Foundations of Tech class. Let's get to it. Checkpoint 2 is now past due for your catapult project. That was the drawing checkpoint. For details about that one, check out the previous 2 videos. Please make sure you work on that and turn it into me as soon as possible if you're still missing it, because otherwise you'll be really far behind. Checkpoint 3, which is to actually build and test out your catapult, is due by Monday the 14th. There is an alternative version if you have no materials posted on my MCPS. You can check that out under this week. I'll show it to you towards the end of this video as well. So if you have any questions, please make sure you email me about that one. Our objectives are that you can identify mechanical advantage in a pulley system today, explain the relationship between mechanical and distal advantages, and identify required qualities in a catapult and create a technical drawing of the planned design. So things we've already talked about and a couple of things with pulleys. So let's take a look at that. That's going to be covered in our warm-up, which was the following question. James is twice as strong as Dave. Dave and James have a competition to see who can lift the most weight using their respective pulley systems on the left and the right. Who will be able to lift the heavier weight? And assuming they're both able to actually get their weight off the ground, which of them will be able to pull it up faster? So there's a lot to unpack here. First of all, you have to recognize that these are pulley systems. In a pulley system, the way you determine mechanical advantage is you have to count the number of ropes that are going to support the movable pulleys. So which are movable and which are fixed? Over here, these two are fixed, and this one at the bottom moves. Over here, these two are fixed, and these two at the bottom are movable pulleys. Next, we count the number of ropes. This system has 1, 2, 3, 4 moving ropes connecting these two movable pulleys. Therefore, this has a mechanical advantage of 4. James has a mechanical advantage of 1, 2, 3. This is called a block and tackle system, where one rope connects to your moving pulley in the center, but still is a moving rope that runs through this anchor and then through the pulley itself. So this is a 3-to-1 system. This has mechanical advantage of 3. So then if James is twice as strong as Dave, it follows that he would be able to lift a heavier weight, since he would be able to lift something that's 2 times 3 or 6 of Dave's normal power, whereas Dave would only be able to lift something that weighs 4 of Dave's normal strength ability to lift. So 6 is more than 4, therefore James can lift a heavier weight. Now the second question, assuming they can lift it, which of them will be able to pull it up faster? The thing to recognize here is distance advantage is the inverse of the mechanical one. So in this case, for every foot that Dave pulls, this lifts up 1/4 of a foot. So to lift this up 1 foot, he'd have to pull 4 feet of rope through. James, on the other hand, has a 1 to 3 system, meaning for every 3 feet he pulls, this lifts up 1 foot. So he is able to also pull up faster, since his weight moves up quicker as he pulls out the rope. So James has an advantage in both cases. He is able to both lift a heavier weight due to his superior natural strength, and his weight is going to move faster than Dave's. So hopefully that makes sense. If not, please let me know. Now let's take a look at your assignment. So if we go ahead and head over to my MCPS, we've got a couple of things for you to do here. Thing number 1, remember, is checkpoint 2. If you still owe me that, that is priority number 1. Now, otherwise, under modules, you will see there are 2 versions of checkpoint 3. There's the regular one and the alternative. For the regular version of checkpoint 3, let's take a look at that one first. What I'm asking you to do is very, very straightforward. I want you to build your catapult design. If it's different from what you drew, because what you drew turned out to not quite work, that's okay. But whatever it is, make it as best as you can. Take a picture of your catapult below, And then underneath here, I want you to go ahead and take a video and attach it to your submission. So on this previous screen over here, you can attach your own files, attach your video there. If you can't figure out how to do that, email me the video. That's fine as well. And then there's 2 questions for you to answer. How far does your catapult shoot? If you have no way to measure this, use the heel-toe method and assume each of your steps is a foot. I know that's not quite accurate, but for our purposes, that's good enough. Just a general estimate is fine. And down here, what is the distal advantage of your lever arm? So the part that actually flings something in your catapult. And to figure that out, it's the inverse of mechanical advantage. That's how distal advantage works. So you would want to divide the distance from the fulcrum to the load, the basket in this case, by the distance from the fulcrum to the power source, the rubber bands. And you should get a positive, larger than 1 value here. That should be your answer. Now, suppose you don't have any materials. What do you do then? Well, in that case, I have a different alternative version of checkpoint 3 for you. Let's look at that one. That one is also very straightforward. What I'm asking from you here is for you to write a short 500 to 700 word essay, not page, that'd be crazy, on what kind of simple machines you encounter in your day-to-day life. So you can order it chronologically, taking us through your day, or by machine type, like how many levers do you encounter. So for instance, a door, well, if it has a round handle, that is a wheel and axle. That's a simple machine. It provides a mechanical advantage because it lets you move that heavy latch easier than if you were to just try to pull on it. The door itself is a lever. It provides mechanical advantage because it's easier to open that lever door due to its hinges. If it didn't have the hinges, it'd be much more difficult. So keep thinking, what other simple machines do you use in your everyday life? I guarantee you there's lots of levers. List them out. Give me a general idea of what kind of mechanical advantage you're looking at. Is it 2, 3, 4, 1? Remember, 1 is no mechanical advantage. It's just a redirection. That could also be the case. And then at the end, give me as well a explanation of whether the machine is standalone or a compound machine, and summarize how your life would be different or probably more difficult without the benefit of simple machines. If you have any questions about this or any other assignment, go ahead and shoot me an email, and I will try to get back to you as soon as possible. I hope you guys have a fantastic rest of your day, a great weekend, and I'll see you next week. Have a good one.